Good evening, class. All right. So, welcome to the fourth session of SQL. Today, we are going to wrap up the topic of entity relationship diagram. I think we needed to stress a bit more on primary key and foreign key. And then from there on, we'll move on to constraints and then we'll start talking about joins. So, starting from today's class, we are going to work with multiple tables together and which are going to be joined by some keys or some columns. And to understand that, understanding how a entity relationship diagram works, what are the constraints you can put on a table is very important. All right. So in the previous class, we went into great detail to understand what an entity relationship diagram is. It is essentially a, a kind of chart which tries to explain the relationships between different entities being tables here. And an entity relationship diagram is specific to a database. And then we spoke about the different components of it. So we spoke about entities, which are tables. Then we spoke about their attributes, the relationship. So basically the columns sitting in the tables. Then we spoke about the relationship, which shows that how, sorry, is there a question? Okay. Then we spoke about how different entities are connected or associated to each other, which essentially tells us the if two tables are connected to each other or can be joined with each other or not. Then we spoke about cardinality, which tells us that what is the kind of relationship? Is it one observation in one table can be linked to one observation in the other table, or one observation can be linked to multiple observations in the other table. Then we briefly touched upon the topic of primary key and foreign key. So primary key and foreign keys are essentially the fields or the attributes which are going to be used to define relationships between different tables. So a primary key, let's understand that first. A primary key is a unique identifier of a table. So think of it like a column, which is going to be unique. Unique meaning that the value of that column will not repeat in that table. It's going to be appearing only once. Second is a primary key can never be null or missing. So these are the two main features of a primary key. Number one, it has to be unique. Number two, it cannot be null. Okay. It when you kind of piece both of these two information together, you can say that a primary key is a unique identifier of a record in a database table. Okay. All right. So we understand what a primary key is. Just to explain, if I go back to my table here. So this is the code that we have been working with. Oh, I forgot. There were 3 questions from day 3. So I'll just finish up this primary key, foreign key thing, and then I'll solve these 3 questions, I think. From previous class, 3, 4, and 5 was pending. So I'll just solve that for you. But now that we've broached upon the topic of primary key, let me quickly start day 4's material. So how do I understand that if a particular field can be a primary key in a table or not? So number one, it cannot be missing. Number two, it has to be unique. So if I say count star, then I say, let's say I'm talking about my customer table. So count ID and count distinct ID from customers table. Customer. So I'm just going to select it from here. Is it customer or customers? I think customers. Okay. All right. So this is the table which has been provided to us and we've imported it here. When I run this query, so this tells me that the total number of observations denoted by count star is 1000. Then the count of ID is going to tell me the number of non-missing records in the field ID in this particular table. So that is 1000. So if the number of non-missing observations in ID is equal to the total count of observations in the table, that means ID is not missing or it does not take null. Third, when I take a count of the distinct ID, so essentially I'm trying to look at the unique values of ID field in the table customers. That is also 1000. So that means from this query, what we can derive is that ID is not missing and ID is also a unique field in the customers table. So because it satisfies both the criteria for a primary key, we can safely say that ID is the primary key for the customers table. Okay. All right. Now we understand the concept of primary key. What about the concept of foreign key? A foreign key establishes links between tables. Okay. So foreign key is basically going to be the column that you're going to use to join multiple tables together. So they facilitate relationships between entities. Okay. So a foreign key is a column. To define it better, I would say a foreign key is a column, or it can also be a group of columns in a table that provides a link between two tables. Okay. So in most cases, the foreign key is going to be, it has to be present in both the tables. Okay. So in one table, it is the primary key, and in the other table, it's called the foreign key. A single table can have multiple foreign keys. So essentially, if one table is linked to multiple tables, then it will have multiple foreign keys. It can also contain duplicate values, and it can also be null. Okay. Now, instead of talking about it in theory, what I'm going to do for you now is I'm going to mark the primary and foreign key in all of these tables. So if you remember, this is the database structure which has been provided to us. Let's go back to the most simplest database first, which is the employees database. So employees database has two tables, employees table and departments table. Now, if you see in employees table, the unique identifier is employee ID. So that means in the employees table, employee ID will be my primary key. If you want to verify that, you can go back to your query and write a similar query using employee ID to check if it is not missing and to check if it is not repeating. Okay, I've already checked that, so I can safely hold on. So I can safely say that employee ID here is my primary key. Okay. Now I know these two tables are linked, so I'm going to draw a relationship line between them. Now, if I go back to my schema again, here, if I scroll down, this says department ID is the unique identifier linking the employee to a department. So because this field is going to link the employee table to the department, it is the foreign key. Okay. So I will go here and I'm going to mark it as foreign key. Now, if you go back to your table and try to see, if I just go back to the table and I open up this the employee table and just do a quick preview, what you will see is the department ID is not unique. It is repeating because each department can have multiple employees, correct? So department ID is the foreign key because number one, it is going to be the linking key between department table and employee table. Number two, in my employee table, department ID is not unique. It is repeating. It can also be null. In this table, it is not null, but for a foreign key, in the table that it is defined as a foreign key, it can also be null. Now, if I go to my department table, department ID is the unique identifier. So I'm going to call it the primary key. So if you see here, the same field department ID, in the department table, it is the primary key because it is the unique identifier which is not missing of each observation in this table. But in my employee table, it is only used to link the employee table to the department table. It is repeating in my employee table and it can also be missing. So for that reason, in my employee table, my department ID is a foreign key. Okay. Now I'll go to the other table, which is present. Not this one. Hold on. The other one, which is customer orders, order details, and products. So the linking we had already done in the last class. We had linked this to this, and this links to this. Okay. Now, in this table, if I go back to the schema again, and this is the first. Yeah. So here in customers table, ID is the unique identifier for each customer. So by that logic, ID is my primary key. I also checked it. There are 1,000 observations and there are exactly 1,000 non-missing unique values for ID in this table. So this is my primary key. Now, if I try to link customer table to orders table, my customer ID is exactly same as the ID field sitting in customer table. Okay. Now, because this customer ID is used to link orders table to customer table, and if you check, customer ID will keep on repeating in the orders table. So that is why my customer ID in orders table is my foreign key. Order ID is the unique identifier of each order sitting in my orders table. So that becomes my primary key. If you think that whatever I'm saying might not be correct, you can go back and check in your table. In a foreign key, in that table, it will keep on repeating. Number 2, it is used to link it to a different table. Number 3, it can also take missing values. In order, and in that in a table, if a particular column is not missing and is unique, then that becomes your primary key. Now let's talk about order details table. If you go to order details table, what you'll see is order ID and product ID. Both of these keys are non-missing. They are used to link it to two separate tables. So order ID is the linking key between order details and orders table. So by that logic, order ID becomes the foreign key here. So first of all, let me call this as the foreign key. Okay. When I talk about product ID, that is the linking field between order details and products table. So this is also the foreign key here. If you go to your table and check, both your order ID and product ID are repeating. And they're used to link it to two different tables. So that's why both of them are foreign keys. This foreign key, order ID, is used to link it to orders table. Product ID foreign key in order details table is used to link it to products table. Now, what about the primary key? In this table, a combination of order ID and product ID, I just call it PK. So a combination of order ID and product ID is actually your unique. So how do I check that? So I will say, select, first of all, I'll just check the count from order details table. So if I check the count, I think it is 14,977. Now, if I check, select distinct order ID, comma, product ID from order details. So this is going to give me the unique combination of both of these fields. If the total number of records of this query is equal to 14,977, that means a combination of both of these fields is actually unique in this table. So if I run this, See here, the total number of observations is listed for this query. It is 14977. So a combination of order ID and product ID is actually unique. So in this case, you can do two things. Number one, you can define a combination of both of them, create a new field, which is a combination of both of them, and call that the primary key. Or you can use both of them together as the primary key. In other words, you call that a composite key. So a composite key is nothing but if a particular table has uh, a combination of more than one field as the unique identifier. Then in that case, you call that a composite key. It's just another word for primary key. But in this case, a combination of more than one column is unique. Okay. If I go back to this table now, in my products table, my product ID is actually unique. So that's my primary key. So this is how all of these four tables are connected to each other. If I want to talk about the cardinality now, in customer table, my ID is unique. In my orders table, customer ID is not unique. So this is a one-to-many relationship, because one single ID can be mapped to multiple records in this table. Okay. If I look between orders table and order details table, the linking key is order ID. Now, order ID in orders table is unique, but in order details table, it is repeating. So again here, the cardinality is one-to-many. Same thing here. Between order details and products, if my order details is the first table, if you go in this order, so this is my first table. So my product ID here will keep on repeating, but here it is unique. So here the relationship is many to one when you go in this direction. If you join products table to order details table, then based on product ID, in products table it will be unique, and in order details table it is repeating. So in that case it will become one-to-many again. But we are going from left to right. Just going to put the directions also. So that's why when I will call this as the first table in the join and this as the second table, it becomes a many to one join. Okay. Now for the last cardinality, I have kept these are all the tables. What I've done is I've just listed out all of them. Now, if I go back to the database structure, the reason I'm marking out the ERDs here is we are going to keep referring to this ERD in the join section. Okay. Sorry. So in the library database, the first table is books table. So books table has the unique identifier as books ID. So first of all, let's go and mark all the unique identifiers. So books ID in books table is my primary key. Okay. Now, if I go to my members table, member ID is the unique identifier. Okay. So I have the members table listed here. So members ID becomes my primary key. If I go to loans table, loan ID is the unique identifier of each loan. So in this table, the unique identifier is loan ID. Okay. So I will go to the loans table. Loan ID becomes my primary key. Now, in the loan table, there are two other IDs. There is member ID and there's book ID. So member ID is the unique identifier linking loan table to member table. And book ID is the unique identifier linking loan table to book table. Okay. So I can join loans to books. Book ID here is the primary key. In loans table, it becomes my foreign key. Okay. Loans table is also linked to members table. It also has a member ID. So member ID becomes a foreign key. Now see, Another small criteria of a foreign key. A single table can have multiple foreign keys, which individually are used to connect two tables. So loans and books tables are linked using book ID. So that's one foreign key in the loans table. Member ID is used to link it to the members table. So that's my other foreign key. And you use these independent of each other. So book ID will be used to link it to books table. Member ID will be used to link it to members table. Okay. All right. What about the other three tables? Let's go back to the schema. So in the schema, there's a publishers table. So publishers tables, unique identifier is publisher ID. So I have the publisher table here. So this is my primary key. Book publisher has two IDs only. It has books ID and it has publisher ID. Books ID is the unique identifier linking the book to a publisher. Okay. And publisher ID is the unique identifier linking the publisher to a book. Okay. So in this case, if you see, your book ID and publisher ID are used to connect it to two tables. Your book ID is going to be used to link this book publisher to the books table. So this becomes my foreign key. And the publisher ID is used to link the book publisher to the publishers table. So this also becomes a foreign key. So you have two individual foreign keys. In this table, again, a combination of both of these fields is my primary key. Because usually what happens if you have a connected table, there's no such word as connected table, but just to explain, this table is just acting as a link between books table and publishers table because it just has two keys and that is used to link it to books table and publishers table. So if I have to join information from books table and publishers table, I will have to use books table, book publisher table and publishers table using these key combinations. So whenever you have a table like this, which acts as a connector between two tables, mostly the IDs, the combination of the IDs become the primary key. Okay. Last, now we have two tables left. You have a libraries table and an authors table. So authors table has author ID as the unique identifier. Okay. So I'll go to my authors table, mark this as the primary key. Now, the linking field between books and authors is actually author. So this is the name of the author. So this is my foreign key here. And this is used to link it to this table, which is also my foreign key. Okay. Actually, there should be an author ID here, or there should be a linking table, something in between, which is missing. So we are simply saying, if I go back and check, then the author name sitting in books table is exactly equal to the author name sitting in authors table. So I'm just using that to link it. Ideally, there should be a connected table between these two as well, which contain the ID of both. Like here, book publisher has book ID and publisher ID. There should ideally be one table here in between this, which will have book ID and author ID, which you'll use to define as the foreign key. But that's not there. So we'll simply use author and link it to name. Now there is one last table here, which is libraries table. Library table has library ID, which is the unique identifier, a name and a location. Okay, so my library ID here becomes my primary key, but there is no linking field in this libraries table with the other table. Actually, what has happened is the schema is missing a couple of tables. The tables which have been provided in that, a couple of tables are missing, which will essentially create the relationship of libraries table to the other tables. Ideally, libraries table has to be linked to members table with a connected table in between, which is missing. So based on the schema which has been given to us, you cannot link libraries table to the rest of the tables here. So in such a scenario, which is not a great design for a schema, but if such a scenario occurs, this is called an orphan table. Usually that doesn't happen because in a relational database, you should be able to create relation between all tables. What I mean by that is, if I want to have information from members table and say authors table, I will have to first link members to loans, loans to books, and books to authors. All four tables have to be connected to each other in the join clause so that I can pull information from this table and this table. Now, the reason I can do that is because all of these tables are interconnected to each other. So an orphan table breaks that relationship. Actually, there is a table which exists between them, but because that's not provided to us in this scenario, we'll call this an orphan table. In an ideal scenario, you shouldn't have an orphan table because you cannot link or use its information in conjunction to the rest of the tables. Okay. So now we have the ERD defined for all of these schemas. Okay. Any questions on this part? Oh, there is no one. Okay. All right. So give it a try. And what I would suggest for you guys is, like we have defined the cardinality over here, check between these tables in a particular schema, look at the connected tables and try to understand what is the cardinality. For example, when you connect employee to department, is that a one-to-one mapping? Is it a one-to-many? Is it a many-to-many or many-to-one? Understand that by looking at the connector fields. So the connector field between them is department ID. So you try to see that, does department ID keep on repeating here? And here, is it unique? So then it becomes a many-to-one when you join employee to department. If you go the other way around, it becomes a one-to-many. So one assignment I'll give you is, for all of these connectors, try to define the cardinality. Okay. All right. So that finishes the ER diagram logic. Now I will move on to a topic which we left earlier, which is types of SQL constraints. The reason I do it after ERD is because you have these two constraints, which is primary key and foreign key constraints. Okay. Now, let's talk about constraints. As you can see, there are 6 constraints listed here. We already understand primary key and foreign key. Primary key is the unique identifier. Foreign key is the referential integrity. So it is used to connect two tables. Basically, that's what they're trying to tell you. This is the way that you create or define primary key in a create table statement. So in the create table statement itself, you can say employee ID. So the column name, which is your primary key, followed by the data type, and then you say primary key. So in this case, I am defining employee ID as the primary key. I'm declaring it as the primary key. Okay. To define a foreign key, you have to, so in orders table, order ID is my primary key. To define a foreign key, you have to write a separate statement. You say foreign key, in bracket, you define which field in this table. So because customer ID is the linking field between orders and employees, so after foreign key, in brackets, you have to mention the name of the field from orders table, which is going to be the foreign key. References to which table? So what is the connection? I'm trying to link my orders table to customer table. So then I will say references, table name that I'm trying to link to the orders table using this key, and then the key in customer table, which is going to be linked. Okay. Now, I will show you both of these. The only thing that you should keep in mind is that in BigQuery, the primary key and foreign key constraints are not enforced. So even when I'm going to write the query, I have to write in the syntax has to include the words called not enforced, which mean that the primary key can actually be missing or it can be repeating in BigQuery. The reason primary key and foreign keys are defined in BigQuery is because it makes merges between heavy tables very fast. Think of it like a performance enhancement feature. But ideally, in RDBMS, a primary key is a unique identifier which cannot be null. and a foreign key is used to link two tables. Okay, so to explain these two, I will also write the query in MySQL. I have the interface installed, so I can write the query and show you what exactly happens if I try to feed in values which are repeating in a primary. Okay, but before that, let me go through all of these constraints first. So a not null constraint ensures that a column cannot have null values. As the name suggests, not null. The syntax for that is the field that you want to define as not being null. After writing the name of the column, the data type, you mention not null. That means this column can never be null. A unique constraint ensures that all values in the column are unique. Simple. So in the same way, you define the name of the field, the data type, and then the constraint unique. So this means that in email column, you can never have repeating values. Default constraint, I'll talk about check at the end. Default constraint means that you provide a default value for a column. So here you say join date, which is the column name. Then you say date, which is the data type. Then you say default, which is the constraint, and then get date. Get date is a function which is going to get the system's current date and feed it to join date. So whenever I'm trying to feed values in the employees table, even if I forget to give a value for join date, it will automatically get populated using this get date function. We'll check how that works. A check constraint means that you basically put a check saying that a particular column can only take specific values. The syntax for that is not here, so I will write it down so you understand it better. First, I'm going to define the constraints which we can do in BigQuery, and then we'll move on to then I'll try to show all of these constraints in MySQL because there it's clearer. Okay, so I'm gonna say create table classwork.dpt. I'm creating a table here. Let's say it has two fields, department ID, which is a string, followed by description. Let's say this is going to be the description string. And the way you define a primary key in BigQuery is you say primary key, in brackets, you mention the field that you want to declare as the primary key for this table. And you have to write these and not enforced. So not enforced essentially means that the non-null and unique constraints which a primary key should have will not get enforced. We'll see what that means. Let me run this. So this is creating my table. Now I will create one more table. Create table classwork.constraint. And here I will feed in ID, which is a string. Sorry, just enter. Then we are going to use department ID in this table. So this is going to be my foreign key in this particular table. So department ID is also a string. The way you define foreign key in BigQuery is you say references. Then you have to mention references what? So link to which table, which column. So classwork dot department, and in that the connector or the field which is same in department table is department ID. And here also you have to say not enforced. Okay. If you don't write this not enforced, you're going to get an error. Name not null, you can enforce. So not null constraint we'll test here. Next is salary, which is INT64. So here I'm going to give a default value for salary. Let's say the default value is 20,000. So even if I don't insert, I'm going to use an insert statement after this for this table. Even if I don't feed values for salary, it will automatically take this value 20,000 for each row. Okay, that is what this default does. And lastly, I will put the primary key constraint ID not enforced. Okay, so now I'm going to run this table also. So it creates this table for me. Okay, now I'm going to use an insert statement. Insert into classwork.constraint values. So first I'm going to give it some simple values. Okay. What all does it have? It has ID, which is a string. So let's say the first ID is 1. Then I have to give a department ID. So let's say the department ID is 100. Then I have to give a name. So let's say the name I'm giving is Angie. Then I have to give a salary. Okay, here I'm going to define the fields for which I'm going to give the names, the values. So ID, department ID, name, and one second. Right, yeah, that's it. Okay, this is what I'm going to give. I'm not going to give any salary values here. Okay, so when I run this is my first line of the query, or the first row of information that I want to feed. Now let's try out. If I try to give the same value for ID, is it going to let me do that, feed it or not? Okay, so let's say Marie. So what have I done? I'm trying to test whether I can give repeating values to ID or not. Ideally, because it's a primary key, I should not be allowed. But in BigQuery, it is not enforced. So you cannot enforce the non-null and non-repeating criteria. Let's also try to feed a null value to this. So let's say 100 and then John. Okay. So if I run this query now, it has added 3 rows. Let's see how it's looking like. So constraint is the table. If I click on it and I do a preview, see, ID is repeating and ID is also taking null, although it is defined as a primary key in this table. See, so the whole reason of keeping primary key here was that so that ID is not null and not missing. But in BigQuery, you cannot enforce it. So the reason why you still have primary key in BigQuery is because it helps indexing the table easier. It's basically easier to join this table to another table. Right now it has 3 or 4 entries, but mostly you'll have millions and millions of rows. So then it acts upon the performance of the join criteria. So to avoid that, you have primary key and foreign keys. Okay, that's the only reason you have them in BigQuery. They don't serve the other constraint criterias. Okay, so primary key we understand here. Let's try to see what happens if I try to okay, one more thing. If you go to constraint now, look at salary. We did not feed any value into salary, but because in the query, when we created this table, we said salary by default takes 20,000. By default, it is automatically populating this. Okay, so this is your default criteria, default constraint. Now name not null. What I'm going to do now is I'm going to insert one more row in another, and here I'm gonna, let's say, give another ID, and let's say the department is still 100, and here I'm going to try to fill a null value for name. Okay, now here you can see for name we have given this constraint that it cannot be null. So if you run this query here, where I'm trying to fill a null value for name, it will throw an error. So it will not let you. So this is essentially the whole point of a constraint, that when you say that a particular constraint is applicable for a column, if I try to feed that value, it's going to give me an error. Okay. Now, what I'm going to do is, so that it is clear for you guys what exactly happens in a primary key, what happens in a check criteria or check constraint, I'm going to create a database and two tables within MySQL. Okay, this is just for you to understand. It's not very important at this point, which is why it's okay even if you cannot practice. At a later stage, if you're using MySQL, you can apply this logic there. Okay, so in MySQL, first I'm going to create a database. Okay, then create, I have to also say use test. I will tell you what each of these statements do. First, I'm going to create two tables now. Okay, create table department. Department, I'm going to give it two fields. So ID, varchar 10, which is the data type. In BigQuery, we use string to define a string data type. In MySQL, the data type for string is varchar and 10 is the length of it. Okay. And the way you define a particular field as a primary key is you simply say the field, data type, and primary key, which is exactly how it is defined here. Okay. The next is going to be description. This also is, let's say, varchar 10. And here I'm going to give it a default value, which is new department. Okay. Okay. So this is my first table. Now I'm going to create another table. The same tables that I created there, I'm creating it here as well. Constraint 1. First, I'm going to give it value ID, which is varchar 10. So this is the primary key of this table. Then I'm going to use department ID, again varchar 10. Then let's say I'm going to give it a name, varchar 10. So where this has to be unique and not null. I'm going to give it two constraints. So I'm saying name field in constraint 1 table has to be unique and it cannot be null. I am enforcing two constraints here. Then I'm going to say salary, default value 10,000 here. Okay. Now the last one, I'm going to add another field, age, integer type, and here I'm going to define the check. This is how you define your check constraint. So I want to say that age should always be greater than 21. If I try to enter an age value less than 21, I should get an error. Okay, now I will just define the foreign key as well. Foreign, this is how you write foreign key, by the way. The logic to write foreign key like this. When you say department ID, which is the linking key between the two table. References in which table? Department table. Which key in department table? Department ID key. Okay. That's it. Close it up. Okay. So I'm going to run all of this together. Okay. All right. Sorry. So first, this one ran. Okay, create database. This is going to create the database test for me. Now you'll see a test database getting created here in the schema. This is how the schema looks like in MySQL. Then you have to say use test. When I say use test, I essentially don't have to keep writing test.department, test.constraint1. In MySQL, you can do that. You can just write this line of code and then it will use test as the current database. But you cannot do that in BigQuery. So we have to keep referring to the data set name also, which is classwork for us there. Then department table got created. The last query has a bit of an error. That's because here I'm saying references department. The field in department is department ID, whereas in department I've called it as ID. So I just have to keep using the same name. So here I'm trying to say that the field department ID in constraint 1 table is the foreign key which is linked to the ID column in department table. Because I was calling it department ID here, which doesn't exist in the department table. So I got this error. So now I'm going to run this query again. See, now it is correctly created. All right. Now we are going to test out each of these constraints. So I will say insert into constraint 1 values. Achha, for which fields? I want to test it out for, let's say ID, then department ID, then name and age. Okay, I'm going to feed values to only 4 of these columns. So let's say my first entry is 1. ID takes value 1. Then let's say the department is not mentioned here, so I'm going to call it null. Then let's say I want to give a name, let's say Marie, and then age. So let's say the first age is 23. Let's see if this is working or not. Insert into, yes, so it is creating one row. If you want to see what's going on, select star from constraint 1. If I run this query now, forget about this one column. It's actually one row only. By default, it is creating an additional row. Forget about that. In this one row, what's happening? I put in the value for ID is 1. For department ID, I said take a null. For name and age, I gave values. For salary, I didn't give a value. But because when I was writing the create table, I gave this default value for salary. So it is taking that default value. Okay. Now let's try to test for the primary key constraint. So if I take this query again, write it again. Instead of this being Marie, let's say John. Okay. See, what I'm doing here is I'm keeping the ID value as same, although ID is the primary key. For name, I'm taking a different value. For department ID, it's still null and age is 23. If I try to run this query, I'm going to get an error which says duplicate entry 1 for key constraint primary. So see here, if I'm trying to repeat the value in the ID column, it is going to throw an error for me because by default, a primary key has this constraint that it has to be unique. Because I'm trying to define another row with the same value for ID, it will give me an error. What happens if I try to give a null value for ID? Another constraint for primary key that it cannot be null. See, it says column ID cannot be null because it is a primary key. Okay. So these two things did not happen when we tried to insert a repeating value or none value in the primary key in BigQuery. So just to show what happens, I'm running this code in BigQuery in MySQL as well. Okay, so this part is clear. Now let's try to understand for name what happens. If I go to this and instead of null, let's say I give a ID 2 and I try to see John, this column never got created because we got this error. So if I say Marie here, so I'm trying to define for another person whose name is the same. Let's see if it lets me do that. Duplicate entry for Marie. We have a constraint here on name because when we defined the name column in this table, we said it has to be unique. Similarly, if I try to repeat the same and instead of this taking a value, if I try to feed a null value for name, again, if you remember in name, we gave it another constraint, not null. So both is going to throw me an error. Okay, We understand that. Let's see what happens in this case. So now, if I try to insert a column here, let's say, let's create a new ID3 in name. Let's say we give it a name as J. And in age, if I try to give 18, now remember the age constraint was, the check constraint on age was that age has to be greater than 21. And what am I trying to do here? Pass a value for age which is going to fail that constraint. Let's see what happens. See, check constraint is violated. So it's not going to let me insert any of these values. If I go back now and I run this query, I want to see what observations. See, there's only one single observation for Murray. All the others did not get inserted because they were violating one or other constraint. Okay. All right. So I just wanted to show this, that what happens in a check constraint, what happens in all of these constraints. So we did this. Okay. That's about constraints. Let me go back to the table. Yeah, so these are the 6 type of constraints that you can apply on your table and use them. In BigQuery, you can see the proper application for not null and default only. Unique you cannot apply, check you cannot apply. So, and primary key and foreign key you can apply, but they are not enforced. So the actual properties of that you cannot see. So that's why, to see all of them clearly, we have tried to look at it in MySQL, which is kind of like the main, one of the main RDBMS which is used. All right. So if you are really interested in this, then once you get conversant with using coding in SQL on BigQuery, you can try installing MySQL at a later point in time, and then trying to understand what happens. At this point, I would not say this is very important for you to do. So just for your understanding, I have coded all of this in MySQL, and we are putting this in the class so that you can follow what exactly this means. All right. Okay. Now I'll very quickly finish off the 3 questions which I am missing again and again. So from day 3, there were 3 questions. I will quickly give you the solutions for all 3 of these, and then we'll move on to joins. Okay. Let me see. Where is the, this is the question. Question number 3. Question number 3 says, find the count of employees by department and city whose salary is greater than 10,000, sorry, arrange it by count in descending order. Okay. Let's go back to our BigQuery. So now I'm gonna give you day 3 solutions. So we want department ID and city. So I'm gonna say department ID, city, and we want count of employees. So I'm gonna say count as count employee, give it a nice name, from classwork.employee. Now there's a condition where salary is greater than 10,000. Okay. And then we have to group by department ID and city. So I can use the alias 1, 2. And we have to arrange it by their count in descending order. So order by 3, descending. If I run this now, oh, okay. I cannot refer to this in capitals. I forgot this. This error came because it's saying there's no such data set as classwork. This happens. BigQuery is a little weird when it comes to a case. So it is okay with accepting the case for department ID and city, I think. But for table names, I have to give the exact way that it is written. So it's in small case. If you see, its classwork is in small case and the name of the table is also in small case. So I have to exactly follow that. All right. But for the column names, it's okay, accepting it in a different case. All right. Just a small quirk. Ideally, this doesn't happen in other DBMS. All right. So this is how the output will look like. Arrange it by, okay. Next, find the count of orders by kiosk where sum of value is greater than 30. So this is referring to the table records which we had created. So we have to say select kiosk ID. Then what all fields do we need? Count of orders. So I'm going to say count star. And the other is where sum of value is greater than 30. So what I'm going to do is just write out sum of value here so that it's clear what's happening. From records, I'm going to select it from here, group by 1. Okay. So when I run this is going to give me the number of observations or the number of orders which were placed by for each kiosk. So 5 each. And this is giving me the sum of value of purchases happened at each kiosk. Now, the question says that I want to find only those observations or those output where the sum of value is greater than 30. So because it is going to be based on an aggregation, we have to use having here. So having sum of value greater than 30. It won't make a difference to the output, but this is where we use having, where we want to basically filter the output based on an aggregated field which we are creating. Okay, last question, question number 5. Question 6 we had done in the class, so I'm going to only do question 5. Find the sum of price count of items from products table by category. Okay, so I'm going to say select by category. So I'm going to say category. We'll do another few enters so we can see what I'm writing. Sum of price and sum price, and second is count of order as count product from products table. Okay, group by 1. So this is my first part. Sum of price, count of items from this. Filter out categories, jewelry and clothing. Okay, let me run this query first. The first part of the query is this. So here we see by category the total sum of price and the total count of products from the product table. Okay. Now, the second part of the question says, filter out categories, jewelry and clothing. Now, because this is based on a raw field categories, we are going to use where to do the filtering. Where category in, because I want to filter out 2, which is 2 values for this field. I'm going to use in jewelry, and the other is clothing, I think. Clothing. Okay, not in. I'm sorry. So this says filter out. Filter out means get rid of this. Where category. So when you want to use not operator with in, this is how you write it. Okay. So if I run this query now, you will not find output for jewelry and clothing. They were at the very top. So they don't exist anymore. Last part is keep only aggregations whose minimum price is greater than 30. Now to understand what's happening here, I'm going to add minimum price here. First this, and then we run this. So this is giving me the minimum price by each category. So if you look at the output of this query, you will see that greater than 30. So that means if I apply a filter on minimum price using having, it's only going to retain home appliances, kitchen appliances, and then furniture, because only for those the minimum price is greater than 30. Let's see if that's having. having minimum price greater than 30. Now, because I'm applying the filter on an aggregation, I have to use having and not where. Run it. See, only these three come out. Okay. I hope all of this is clear, because now we're going to move into a topic where we are going to refer to multiple tables together. All right. I'm pausing in case you guys have any questions or doubts. I'm not sure if anyone is, okay, there's one person. Is it clear, or are there any doubts in the topic that we've covered today? Okay, great. All right, so we're going to start talking about joins. Of course, we cannot finish it in half an hour, but we'll try to cover as much as possible because we're going to take a break after today's session. So I want to cover as much as possible, and then I'll give you some homework. Okay, joins in SQL are used to combine rows from two or more tables based on a related column. So now, from now on, we are going to look at multiple tables together. This is where all of that ERD diagrams which we created are going to come in very handy. Now there are four kinds of joins. Mainly, there are two others as well. There's cross join and full and self join, but that we'll tackle later. The main ones are inner, left, right, and full. Now I believe you guys understand the concept of join because you must have done similar exercises in Python. So an inner join will give you the matching values between two tables, matching based on the key. So if you look at this query here, this is going to give me the common observations between books and authors where this match is found. So for all of those observations, where author ID in books table matches with author ID in authors table, I will get those rows information using an inner join. Okay, we understand this. Let me also talk about left join, and then we'll look at examples for both of them together. In a left join, what happens is it will retain all observations from the table which is on the left. Left means after from, the table that you're specifying becomes your left table. Okay. Then you say left join here instead of inner join, and then the key. So the match is still going to be on the two keys. The final output will have all observations from books, and from authors, it will only get those column values where this match is satisfied. Let's look at some examples to understand what is the difference between both of them. So I'm going to go back to my query. Joins. Okay, so I'm going to join employee and department table first. If I go to my schema, which we created with so much pains, we know employee and department table are going to be linked using department ID. So let's do that. So the way you write a join is, this is going to create a query for join. So it's going to give you an output. So I'm going to say select A dot star, B dot star from employee A. I'm going to say what A and B is, but let me first write down the query. Inner join department B, and then I have to specify the join criteria. So what is the join criteria? It is based on department ID. So I say on A dot department ID is equal to B dot department ID. All right. Now what is this A and B? What I'm trying to do here is I'm creating a shorthand for each of these tables. So I'm saying that in this query, classwork.employee should be referred as table A. I'm just using an alias for employee table as A. Similarly, department table's alias in this query is B. Why is that useful? Because When I want to refer to fields from employee table, instead of writing classwork dot employee dot column name, I can simply say a dot column name. Similarly, from department table, if I want to refer to a particular column, I don't have to write classwork dot department dot the column name. I can simply say b dot column name, which is exactly what we are doing here. Okay, so we understand A and B. A dot star means I'm telling SQL to pull all columns from employee table. A dot star means A is employee table. So I'm saying all columns sitting in employee table should be displayed in my final output. Similarly, B dot star means all columns sitting in department table should be displayed in my final output. Okay. Now on is very important in a join because this is where all of these primary key, foreign key logic comes in. So we know that the joining key between these two tables is department ID. Now, how do I define that in the query? So we say table A, inner join table B on what key? A dot department ID is equal to B dot department ID. So wherever this criteria is satisfied, so wherever I find a matching entry for department ID in employee with department ID in department table, pull all of those rows here and give me as the output. Let's see. If I run this query, what happens? So now you see there are 299 observations, which is exactly equal to the total number of observations sitting in employee table. Because based on department ID, all observations in employee table find a match with the department table. Let's look at the output here. If you see, first it is listing out all the columns from employee table. So there's employee ID, name, department ID, hire date, city, and salary. And then it is listing out the columns from the department table. This department ID underscore 1 is created because it is referring to the department ID from department table, so that there is no confusion between the department ID columns in the final query. So this is coming from the first table. This is coming from the second table. Some RDBMS create multiple columns for the keys. If you say A dot star, B dot star, some RDBMS will not show you the same column again and again. So if you run the same query in my, sorry, is there a question? Okay, so if you run the same query in MySQL, it will not create this from department table because department ID already exists in the final query output. Okay, then this is the column pulled from the department table, which is department name. Okay, so this is the basic syntax for an inner join. What if I don't want all the column names from both tables? So let's say from table A, I only want, let's say, employee name, employee ID, and city. So I say A dot employee ID, A dot name, A dot city. And from department table, I want only department name. So I will say department name. Okay. And then I simply copy this query where I say from table A, inner join table B on join criteria. So instead of saying A dot star, B dot star, I'm listing out only certain columns from both tables. So now you see only the 4 columns that I specified will show up here. Okay. Now, what if I want to filter based on a criteria? What if I only want to see the output for department name IT? Okay. So right now I'm getting all the observations. That means department name takes all values for department. There are 5 departments, so you find all observations for all employees. If I want to filter this output for only department name IT, how do I write it? First, the entire query. Then I can say where B dot department name is equal to IT. I simply write this. Let me run this query and see if it is doing what I want it to do. See, now the total number of observations in the query is 26. The actual total number of observations for the inner join is 299. If you scroll through, you'll see it only shows you output for where this criteria is satisfied. So what did it do? First, it did this join. Then it applied this filter on the join output and gave you the final output. Another way to write this is, if you want to write it in a different way, you can also write it like this. I'm going to just copy this query because I don't want to keep on writing the same query again and again. If I say and, so here what am I doing? I'm writing select 4 column names from table A, inner join table B on, this is my join criteria 1, this is my join criteria 2. So the difference between this query and this query is how the algorithm will run. Here, it is going to join it on all observations. So all 299 joins will be created and then the filter will be applied on that 299. Here, the join is only going to happen for 26 observations where both of these criteria are satisfied. So if I run this, you'll see you'll get the same output. See, 26. So this query is, in terms of performance, this is better because it filters during the time of join. Here, first the join will happen, then the filtering will happen. So when you're joining very big tables, it is better to use an and criteria instead of a where at the end. Okay. Okay. So this is one kind of logic. Now, what's happening in this table? Now, if you remember from this logic here, you know that in this table, department ID is repeating. It's not a unique key, but in this table, it is unique. So this is a many to one join. Now, what if I want to roll up this table and then join it to this? What I mean by that is, what if I want to look at the total number of employees for each department? Now, in department table, employee information is not there. All I have is department ID, is department name. So what I'm going to do is I'm going to join my department table to employee table. But instead of joining it to the raw employee table, I'm going to create a summary or an aggregation on top of this and then join it. Let me write the query. So I want department name. So I will say a dot department name. Then here I want to find the total number of employees for each department. So I will say count b dot employee ID as emp count. Okay. From now I have to join two tables, so that will come here. So first I will say department. Sometimes it takes it. Yes, department is my A table here. Inner join employee table, which is my B table here, on A dot department ID is equal to B dot department ID. Now, because I am doing a count here, which is essentially an aggregation, there has to be a group by. So the way to write group by here is you say group by, and then you have to list out all columns that you have here except for the aggregation. So here you have to write A dot department name. When you run this query, let's see how the output looks like. And then I'll explain how the algorithm is running. See, for 10 departments, you have the actual employee count. Now, how is this algorithm running? It is first picking department name from this table. Then it is saying that it wants to do a count. So first what it does is, it is first creating an implicit table joining both of these tables. So that is a one to many join, because the department ID in department table is unique, but in employee table it is repeating. So it's a one to many join. Then it is going back to the query and seeing that, okay, I have to retain department name, and from the other table I have to simply group it by employee ID and group it by department name and then list it out. So for all those 299 entries, now it is doing a group by or a summarization, and it is creating a final output where your department name is not repeating. When we ran these queries, the department name kept on repeating because it was a many to one join. Now, because of this whole aggregation that we are putting it, the final output will be a one to one. Okay. We'll look at some more examples on this. We'll look at some more examples when I'm doing the assignments for you. This is just so you understand that how do you roll up a table and then join it to another table. You can also join multiple tables together. Okay. So for multiple tables, we are going to refer to this particular schema over here. So I'm going to join customer orders and order details table, all three of them. So I will say select a.id, a.name from customer table. From orders table, I will say order date, and from order details table, I will say quantity. From. Now I have to join. I'm pulling columns from all three tables. So I have to mention two joins now. First join will be between customer and orders table on ID column. So I will say from customers A, inner join orders table B, and then I have to specify the key on a.id is equal to b.customer ID. Now I'm joining a third table here, order details. Order details is linked to orders table using order ID. So now I have to say inner join. Now I don't have to specify table A, because table A here for this second inner join is this entire thing. Okay. So here I just have to say inner join to which table. So my third table is order details. So I say inner join order details, table C on B dot order ID is equal to C dot order ID. Okay. Run this query. See, I have pulled all the information from three tables. So here I'm doing a multi-table join and joining two tables. So first you have to specify join table 1 to table 2 on the join criteria. Then join to table 3 on the join criteria. You can join n number of tables using the same logic. This I'm showing just so you understand how to join multiple tables together. Okay. Now I'm going to talk about left join. So up till this point, we have done an inner join. Inner join means it will only give you matching rows between or matching observations between the tables that you're trying to join. In a left join, all observations from the first or the left table will be retained, and only matching observations from right table will show. Let's look at one example. I'm going to join customer table to orders table, and I will use a left join now. So I'm going to use the same query. I will not keep quantity because I want to only keep customer and orders. So I'm retaining ID and name from customers table and order date from orders table. Okay. and then I just run this query. And sorry, I have to do a left join. Sorry, I want to do a left join between these two tables. So I run this query. Okay, so the total output is 5007. What I'm going to do here is I'm going to go and just sort this, because what it will do is if there is any missing in the order date, no, when I sorted it in ascending order, the nulls will come at the top. So what's happening in these 7 observations? For these 7 observations, I have an entry in customer table, but no matching entry in orders table based on this logic. So essentially, this ID 28 with the name Jonathan Olson exists on customers table. But if I try to find the ID 28 in orders table, I will find no such entry. For that reason, because I'm doing a left join between customers table and orders table, all observations from customers table are going to be there. Okay. But from orders table, only matching entries are going to come up. Okay. So because in orders table for these 7 IDs, there is no matching entry. So order date, which is pulled from orders table, is going to take a null. Okay. So this is how this logic is different than this logic. If here, instead of doing left join, I had done inner join, it will only give me the matching 5000 entries. These 7 entries will not show. If you run this now, see, it will only give you 5000. And if I sort this in ascending, there will be no missing values. Okay, but we're looking at left join, so I will change it. Okay, now, what I'm going to do is, all right, what I'm going to do now is show you another. You can also use the same logic to join multiple tables. So if I want to join again customer table and orders table and order details table using left join, I will use the same logic. Okay. Now let me show you a summary join. Summary join means that I understand that if I go to my schema again, my orders table and order details table is a one-to-many join. That means order ID is not repeating in orders table, but it is repeating in order details table. So for each order ID here, from the orders table, if I want to pick order ID and order date, and from order details table, I only want to find the sum of quantity, then that becomes a summary join. So I'm going to do that using a left join. So I will say select a dot order ID. What happened? A dot order date, comma B. For quantity, I want the sum. So I will say sum of B dot quantity as total quantity from orders is my A table, left join, order details is my right table on A dot order ID is equal to B dot order ID. Now, because I'm doing a aggregation here, I will have to include a group by. So I say group by. And then, because there are 2 fields here, apart from the aggregation, I have to write both of their names, or I can refer to them as 1 and 2. So this is my first query output, second query output, third query output. So this is 1, this is 2, this is 3. So in group by, I will say group by 1, 2. And let me also say order by 3, so that it is sorted by the total quantity. Oh, this always happens. I have not mentioned the data set name here, so that's why it's giving me this error. This is just a pain in BigQuery because you cannot specify the current database. So see, for each order ID and order date, I have the corresponding total quantity coming in from order details. If you scroll down, maybe actually just sort this. You will see other order IDs with multiple orders. So essentially, if you go and see what's happening for order ID 4440, there are going to be the total quantity on order details is going to be 46. Okay. Now I'm going to quickly touch upon right join and full join. So you actually, yeah, okay, I'll just touch upon it, and then I'll give you guys homework from your this file. So there is a SQL practice question file. There are questions that you can work on it based on whatever we have done till this point. And anyway, I will try to solve the major ones, and if you have doubts in any of the other ones, we'll solve those. For them you have solutions also. Just a just a small word of caution: not all of them are correct, or not all of them are aligned to the schema that you have. So you will have to check the schema and then write the query. But in order to do this, I will quickly show you right join and full join. So in right join, what I'm going to do is I will create a copy of the loans table and add another entry to it. Okay, so I'm going to say create table loans. I will finish this and then we'll close today's session so that you have something to do when I'm not taking a class over the next week. Loan ID INT64, member ID INT64. I will explain what I'm doing. I'm basically creating a core table which is exactly similar to loans, and I will add another row to it, which will be non-matching. Return date. Okay, first I will create this. Then I want to insert all rows from loans into loans copy. So I will say insert into this. Select star from. Okay. So first I'm creating a table loans copy which has exactly the same columns as loans table. Oh, this is in caps. All right, let me run this again. Okay, so first I'm creating this. Then this next line says insert into this. So I'm trying to insert values into loans copy. And instead of writing values and manually putting in each of these values, I'm saying select all observations from loans table and put it into this. So I will say this is the syntax for that. So I created an exact copy of loans table into loans copy. Now I will write another insert into class work dot loans copy values, and now I will give it values. Okay, I'm creating an additional row here, basically 2024 01 20. So this is my loan date and the return date is 7 days after. Okay, the reason I'm doing this is because otherwise you won't understand how a right join is different. If I now show you select star from loans copy, we run this query. See, now there are 6 member IDs with like this. Now, based on the schema, I am going to join members and loans table, loans copy table, and I am going to use members as the left table. So I will say select a dot star comma b dot star from members A right join loans copy B on A dot, the linking field between these two tables is member ID is equal to B dot member ID. Now remember, your loans table has one extra entry with member ID 6. If I now show you your members table, it has 5 entries which take member values 1 to 5. So when I write a right join, it's the opposite of a left join. In a right join, all entries from the table on the right will be retained. That means your member ID will take values from 1 through 6, and the matching entries from members table. Okay. In a left join, what happens? All entries from left table are retained and matching entries from right are kept. This is just the opposite of that. So when I run this query, my member IDs, name member ID not found. Oh, sorry, it doesn't have an underscore in between. Okay. So see what's happening here. Member ID, name, email, and join date are coming from members table. Now for the 6th member ID, which is the one which we created in this, there is no matching entry in the members table. There is no matching entry for member ID 6. So for this record, all of your information coming from members table is going to be null. Okay. It's just the opposite of a left join. So the same logic applies here also. In a full join, what happens is all entries from both tables are going to be retained. To understand that, let me quickly do a left join also. So in a right join, I know for member ID 6, there is no matching entry from members table. If I do a left join between members and loans copy, all entries from members will be retained and matching entries from loans copy will come. So for the 5th member ID, there is no matching information from loans copy. If you open up your loans copy table, your member ID takes value from 1 through 4. See, 1 through 4 and 6. 5 is not there. So when I'm doing a left join between members and loans copy, for member ID 5, in members table, that is going to be retained because that is my left table. And from right table, only the matching entries will come. When I do a full join, it will show me all observations from members ID, all observation from loans copy, and give me the matching entries also. So if I quickly run this out for you, instead of left join, I write full join, and I run this. Now you have 7 entries because one entry is for member ID 6, which is essentially the non-matching entry from loans copy. And one entry is for member ID 5, this one, which has no matching entry in my loans copy table. So a full join is like a superset of your left join and right join. Okay. I had a set of questions also, which I wanted you guys to try. So what I'm going to do is, I'm going to give you all 5 of these questions. I will solve all 5 of these questions in the class. This is based on all the stuff that we've worked on today, mainly joins, because that's like a very important topic. So I want you guys to understand that. I'm pasting all 5 of these questions, which are my questions. So I want you to give it a try. See whatever you can do. If you cannot create, if it is giving you an error or you're not getting the correct output, we will check all of these 5 questions in the class. And from this Innovit SQL, I don't know why I can't see it. Hold on. From this file, SQL practice questions, I want you guys to try these questions. This covers all the topics that we have worked on till now. Okay, so from that, this has the solutions also. Most of the solutions are correct. Some of the solutions are not exactly based on the schema. So check out your table and then work on it. If you face any errors, I'll help you with that. And some of the questions I've identified, which I want to share with you, so I will share them anyway. So this is your homework uh, for the next week, because I think we're going to talk next on 7th of November. So give it a try, work on the joints, work on all of the things that we've done till this point, and I'll talk to you on 7th November. Hope you have a good session. Come up with doubts so that we can explore more on this. And thank you so much and have a great Diwali. Thank you, guys. Any
Same to
questions?
you, Miss Kosh.
Thank you. Any questions, Rajeshwari, from your side, or are we good to close the session?
I will close the session.
Okay, thank you so much. Bye bye. Have a good evening.
Bye bye. Yeah, good night.